Welcome to The Explainer. So, have you ever stopped to think about what the next big thing, the next huge tech leap is actually going to be made of? Well, today, we're going on a hunt for the materials that are literally going to shape our future. And yeah, we're going dragon slaying, just maybe not the kind you're picturing.
You know that ancient call to adventure, here are dragons? It's still out there. It's just that today, the explorers are physicists. The dragons? They're these undiscovered compounds with world-changing properties. And the maps? Well, they aren't drawn on parchment anymore. They're charted in the digital world of atoms and elements.
The great frontier isn't some distant continent anymore. Nope. It's the almost infinite number of combinations you can make from the periodic table right in front of us. And these combinations hold the secrets to everything, from new superconductors to revolutionary magnets. So, who exactly are these modern-day dragon slayers charting this new territory?
Well, they are the pioneers of a field we call new materials physics, and believe me, they are rewriting the rulebook on what's even possible. I mean, you gotta love this definition from the source material, right? It's this awesome hybrid field, and the people who work in it, the author calls them conversational charlatans. Basically, they have to be master communicators, able to speak the language of a whole bunch of different disciplines, all to design and find these substances with properties that are just, well, they're incredible. The author tells this great story about a colleague who insisted that all of physics could be found in just one element, silicon. And his response was this joke. See, relying only on silicon is like trying to eat nothing but potatoes. The real flavor, the real potential for new technology is in exploring the entire menu of the periodic table.
Okay, so every good explorer needs a map. And for these physicists, their map is something called a phase diagram. But this is not the boring diagram from your old physics textbook. This is a straight-up treasure map to brand new worlds.
A standard phase diagram, the one for water, just tells you how one thing behaves. But a compositional phase diagram, now that is a true treasure map. It shows you what new lands, what new solid materials you might discover when you start mixing different elements together and messing with the temperature. So in theory, the journey sounds pretty simple. You start out in this sea of hot, liquid metal. Then, as you cool it down, you hit a kind of shoreline, and poof, new land appears. Solid crystals, your treasure, start to grow right out of the liquid.
Of course, it's almost never that simple, right? Instead of one perfect, beautiful crystal, you usually get this, a mess, a jumble of different solids all mixed together. And this is where the explorer's real skill comes in. It's one thing to have the map. It's a whole other thing to actually navigate these tricky waters.
So, to deal with this messy reality, physicists have to become chefs. They turn their labs into these amazing, high-tech kitchens, using really clever recipes and techniques to try and coax those perfect single crystals into forming.
The author frames this whole process with this perfect quote. Growing crystals isn't just a rigid science. It's a craft. It's something you learn by doing, with practice, intuition, and probably a lot of failed experiments. It's part science, part art.
Now, their most versatile recipe is called solution growth. And honestly, it's kind of like making rock candy, but, instead of sugar and water, you're using exotic metals at over 1,000 degrees. You dissolve your ingredients in a liquid metal solvent, they call it a flux, which basically helps the right atoms find each other. Then you cool it down super slowly, and finally, separate your crystals from the leftover goo.
And this separation step it's just wonderfully dramatic. They take this glowing hot container, the crucible, right out of the furnace and stick it into a centrifuge. It then spins at these incredible speeds, creating forces over 500 times the force of gravity. That's more than 500 Gs. It literally flings the leftover liquid away, and what you're left with is this treasure trove of pure, perfect crystals.
So what is it that actually drives these explorers? Well, the source material breaks it down into three main kinds of quests, each with its own mindset. You've got the perfectionist, the architect, and the pure explorer.
The first quest is for the perfectionist. This is all about chasing down a known, almost mythical compound, something that theorists have predicted should exist, but nobody's been able to actually make in its perfect form.
The perfect example here is the hunt for quasicrystals. For ages, everyone believed crystals could only have a few specific kinds of symmetry, and five-fold symmetry was considered impossible. The desire to create these crystals was so intense it actually forced them to invent new tools just to handle the ridiculously volatile ingredients. And the reward? Absolutely stunning crystals that looked like dice from a fantasy game, proving once and for all that these weird, impossible materials were totally real.
The second quest, that's for the architect. This isn't about finding something that's already known. It's about designing a brand new material from scratch to have a very specific, very exotic property. A superpower, if you will.
For example, researchers wanted to create a material where all the tiny internal magnets could only point in 4 specific directions, like a 4-state clock. This was a real negotiation with nature. They actually made a checklist, a TET list, of strict rules for the crystal structure and the elements they could use. And what's incredible is by following that list, they were led directly to a compound that did exactly what they wanted it to do. Design became discovery.
And the final quest? Well, this one is for the pure explorer. This is about parachuting into a totally uncharted part of that treasure map, driven by one simple, powerful question. I wonder what's out there. You know, sometimes an accident becomes the best clue. One unexpected discovery of a new quasicrystal gave explorers a hunch. Maybe these strange materials like to hide near other compounds that have similar structures. So they followed that hunch, explored the right neighborhood on the map, and bam, they found a whole new family of them. It just goes to show how happy accidents can lead to absolutely groundbreaking science. So why do all this? These quests, whether you're hunting for legends, designing superpowers, or just exploring the unknown, they're so much more than just academic exercises. They are the engine of all technological innovation. It really all boils down to this simple, powerful cycle. Think, make, measure. You get an idea, so you make something new. You measure its properties, and those measurements spark the next big idea. It's this continuous, creative loop where every single discovery just fuels the next one.
And that hunt is still on. Seriously. Whether it's a room temperature superconductor or a new magnet that completely revolutionizes green energy, the next huge breakthrough is probably hiding in some physicist's kitchen right now inside a glowing hot crucible. And really, it's not a matter of if it'll be found, but when and who finds it.